Hey everyone, here's a video on writing sine and cosine equations. This is being put together for period 8 because you're missing for NGSS and for you seniors who happen to not come in today on the second of your skip days. This is information you will be responsible for. I'm teaching this for period 7 today, but for period 8 you'll have to come and watch this and then check the answers. This will be on the test in the first week in June, and you are responsible to know this. We kind of have done this before, but things happen in life sometimes, and just the NGSS is out of everyone's control here, but you are responsible for this right here. Okay, so first thing you're going to do here on this page is write the equation in the form of sine or cosine, and the A being the amplitude, B being the frequency, and the number that affects the period. And the first thing you're going to have to do is identify, is it a sine equation or a cosine equation? You can look at the start very quickly here. I'm going to do this super fast because I'm not going to spend a ton of time on it. I don't want this video to be too long. We know that, oops, I don't want this. There's your sine function, sine of x. We know our normal period is 2 pi. And here, I'll do this one in red, is our cosine. Cosine is going to be slightly different. Still have a period of 2 pi, but clearly you can see the sine curve starts at 0, 0 at the origin. Cosine start at the maximum, whatever that amplitude is. Okay, I'll come back to that in a bit. But first thing to do is, what I would recommend is, what we can look at first off for this one is going to be a sine curve. So sine, because it starts at 0, 0. The amplitude is 2, so we know the number in front of the sine will be 2 sine. Now, the question is it just x? Is it 2x? Is it 3x? Something like that. We got to figure that part out. Oops. So now you have to trace the period. So what I would do is I would trace one period. That is the amount of time it takes in terms of x for the function to get back to its original starting position. So in this case, this is 4, and this one is going to be slightly different. I'll just go through this with you. This is nothing to do with pi. Notice the other x-axes are all labeled with pi. So this actually completes it in 4. So we know our formula for period is 2 pi over b. So in this case, our period is 4. So we substitute that in for the 4 and 2 pi over b and solve this. So 4b is equal to 2 pi dividing by 4. B is equal to 2 pi over 4. So that's pi over 2. So that is our b value, pi over 2, and that's going to be attached to the x. This is weird in the sense that 95% of the graphs, probably more than like 99, will have x-axis in terms of pi and radians. This is still in radians. It just doesn't have the pi. So your b values from here on out will be numbers that will not involve pi. This one happens to have pi. Okay, so I'll just kind of go through this one, the second one with you. In this case here, this is a cosine curve because it starts up at the max. So we know it's cosine. Max is 3, so that will be our a value, our amplitude. It's not sine. Come on. 3 cosine. All right, we got to find our period. I'm going to trace this. So our period is 4 pi. Okay, a couple ways to look at this. Our normal period on the sine and cosine curves, our period is 2 pi. So in this case, if it now takes 4 pi, it takes longer. We're going at half the speed. Our b value is going to be 1/2. So if you kind of look at it that way, many times you can do that. So 3 cosine 1/2 x. I will show you how we calculate it using the little equation. But if you recognize it, and it's a nice neat number like 2 pi, 4 pi, half pi, a quarter pi. If it's like 2/3 pi or 3/5 pi, that's something different. But many times you can use our speed or our frequency. If I were to kind of touch back on the frequency, in 2 pi, which I will trace here in yellow-ish, it completes half a period in 2 pi. So that's our frequency, which is our b value. If you're using the formula, period is 2 pi over b. Our period is 4 pi. Put that in for the period, and 2 pi over b. Cross multiply, we get b times 4 pi equals 2 pi. Then we divide both sides by 4 pi. There you go. There's your 2/4, which is 1/2. So you can always use this formula and plug it in. Sometimes it's nice and neat. You can kind of calculate the b another way, but that's just up to you. You can always do it that way. All right. That is your first part. You finish that, and if I look on, we're going to go to the second page. Write the coordinates of 2 max points, 2 min points, and 5 roots for this function. Now, again, we know that we can always graph the sine curve and cosine curve the same way every time. We just change our x value. So if I were to put this right here, it's a sine curve, so I can go ahead and do this. There's 1 period. Now, we don't know what this is right here, but so let me just do this here. We have to calculate that. But as far as our points, the blue points are our roots. Notice I asked for 5, so it's more than what we see here. Our max point, we have this is our max point right here. And a minimum point, we'll do in this yellowish color. That's our minimum point. We got to figure that out. In order to do that, we have to first figure out the period length. So we know our amplitude here is 4, -4. Now our period is 2 pi over b. So in this case, that's nice and easy. It's 2 pi over 3. That's our period. So this is 2/3 pi. Now, again, everything important happens right in the middle or exactly at the halfway point. So we take half of 2/3, which is 2/6, which is 1/3. So that's 1/3 pi. Now, on the graphs, I did not make you put the quarter marks, but at this point, you're going to have to, because this maximum will occur halfway between the two intercepts. So half of 1/3 will be 1/6 pi. And you can kind of count here. This is 1/6, 2/6, 3/6, 4/6. So this will actually be 1/2 pi. So we kind of got different numbers here just because of the 2/3, but nothing that we can't handle. Okay, so now it's just a matter of figuring this stuff out. So as far as our max points, if I do our max, we have one max point here. The x coordinate is 1/6. So this would be 1/6 pi, comma 4. All right, we still need another one. I'll come back to that in a minute. All right, our minimum point. We have one minimum here. That is 1/2 pi, comma -4. That's the only one we see on here. So we'll come back to that. Our 5 roots, we see 3 of them. So 0, 0, 1/3 pi, comma 0, 2/3 pi, comma 0. Oops, time out, messed that up. Okay, we still need 2 more. By the way, with the roots, if you just were to write, let me highlight this. For the roots, if you just put the x value there, that's perfectly fine as well. Now, obviously, if I want more, we need to extend this. So theoretically, I could go ahead and graph this here. But what's going to happen is the distance between this is going to be 1 period length. Because remember, at 1 period, then it gets from whatever its initial starting height was to that starting height again. So that is your 1 period in between those 2 points. If I were to look at this here, this is 1 period length there. So you don't actually need to graph it. 1 period we have determined here, I will highlight this in blue. Our period is 2/3 pi. So what we would do to find the next point is we would just add 2/3 to your x value. So for our max, it's going to be 1/6 plus 2/3. So that should be, that's 4/6, should be 5/6 pi. So obviously I'm perfectly fine, at this point using a calculator, do 1/6 plus 2/3, then math fraction. I'm just going to double check myself. Yep, 5/6 pi. So the next time it hits a maximum point, we'll be at 5/6 pi. Same thing with the minimum. We have 1/2, the yellow. We're going to add 2/3 because that's the period. Math fraction that. That'll be 7/6 pi. Again, I want you to use a calculator for that. 7/6 pi, comma -4. Now the roots are a little bit different. It does go one period, but this is every half period hits the root. So if we look at here, 0, 1/3, 2/3. Next one will be 3/3, which will just be pi, comma 0, and add 1/3 to that, it will be 4/3. Let me erase this here. 4/3 pi, comma 0. Okay, so that's how you will do those problems. Okay, I will post all the answers as well. You can do the same thing here. And then your homework or follow-up, all these will be a fair game as well. Nothing tricky there. It says write the equation cosine, sine. It asks for a minimum. So in this case here, it's telling you what the minimum point is. So if I were to zoom in for this one, I'll wrap this part up here. It says write an equation in the form a sine of x with the given properties. Now, it just says the amplitude is 4. If I were to do this here, here's the minimum. Now that minimum is at the 3/4 mark of the graph. And notice, we know this would obviously be at -4 here, and 4, there's your amplitude. But if you remember, amplitude is always considered positive. So you could figure this out here. You have to figure out the period and what 3/4 that is, which is not unbearably hard. But what you could also do, the amplitude is 4. It could start by going down. So if I were to do this, this technically still is an amplitude of -4. Here you're looking at the 1/4 mark for the value of the minimum. Okay, so that's up to you. So you can put this coordinate here and then figure out what the period is here, or you could put this here, that's 3/4, and then figure out what the period is. Whichever one is easier. I think the blue is easier, but I will leave that up to you to determine. Okay, all those answers will be up online. And again, period 8, that'll be up to you to come see me if you have any questions. But this stuff is something you are responsible for. When I see you on Thursday, then we are going to be going on to something else with graphing of, we're going to add some other numbers in there, horizontal shifts and vertical shifts. And then next week is a little crazy because it is senior picnic and it is physics day. So it's kind of a tough time of year, but you'll have to take care of this. So, all right. See me if you got any questions. Peace.